Hey guys, I'm John Robinson, the Astrotard. This week we're going to be mixing up M8, the Lagoon Nebula, right here on the Deep Sky channel. This is Jasper, Tennessee. It's absolutely gorgeous here. Unfortunately, we've had clouds for basically 2 weeks straight. The entire time I've been here, we've had clouds. But I at least wanted to give you a flavor of the sense of the beauty of the surroundings that are here. It's absolutely gorgeous here. This mountaintop community, 1,000 feet above sea level, overlooking 3 states, Alabama, Georgia, and Tennessee. Right here in the corner of East Tennessee, Jasper. Today, I'm going to mix up the M8 Lagoon Nebula. Given that it's been overcast for 2 weeks straight here in Jasper, Tennessee, I'm going to go ahead and mix up this beautiful Hubble Palette version and the true color version of the Lagoon Nebula. I captured all of the subs in Dallas, and what I'm going to do for you today is mix it, showing you every step that I use in PixInsight. I've had a lot of you guys out there ask me in the comments in the previous videos to please show the step-by-step that I use for PixInsight. So I'm not going to miss any step. You're going to see the dirty details here, and maybe I'll have to edit the video a little bit so it's not so boring and doesn't take so long. But here it is, step-by-step. M8 Lagoon Nebula. All right, so step one, we're going to look at the subs here. So we start out by going into where I keep all these things, under refractor, under M8, and under light. So I've got 203 subs here, and roughly 70 or so H alpha, oxygen, and sulfur. These are Astrotard 3 nanometer filters, and I've got these are all 5-minute exposures. So all said and done, 200 times 5 minutes is call it 17-hour exposure. So these are the subs, and my first step is we're going to go ahead and use this script here. I'm going to use the batch preprocessing, not the weighted batch, because I've had some trouble with the weighted batch preprocessing with this particular laptop. It sometimes crashes. Since I'm not doing this on my super fast Astro PC, I'm doing it on this laptop. We're just going to do the regular batch preprocessing. So we'll add the bias files here, and the bias files are located in an older directory from the spring when I captured the bias. There's the bias file there, and these are 5-minute exposures. So I'll get a 5-minute exposure flat file, a dark file, with 139 gain setting, which is what these are captured at. 139 was my gain. Now the flats file was a different set of configuration files. It's under here. It's under April 2020, and we're looking for H, O, and S. And these were, the gain doesn't matter so much on flat files, I've found. Doesn't seem to matter. And then choose master bias, darks, and flats. We'll choose our lights now. So the lights are in the M8 Lagoon Nebula here, and I've got the M8 Lagoon Nebula. This is a 2x1 panel mosaic, so I'm going to do this twice. Here's the first set the dash ones, we'll choose a reference image here. It doesn't matter which one. I usually like to use an H alpha, so that's good enough. We'll use that one. And we'll choose this directory here, M8 Lagoon. This will be quadrant 1 here. And we'll check the diagnostics. No errors, it all looks okay. We'll let that run. Okay, now that that's done, we'll clear out Q1 and we'll repeat the process for Q2. So we'll just come up here and say clear here. We'll say add lights. We'll come down here and we'll find the Lagoon-2 files. Add those in. We'll choose a different reference. Make sure it's an H. It is. And we'll change this to be Q2. All right, and check the diagnostics here, no errors, and we'll let that run. Okay, they're all finished now, so let's have a look. Well, we don't need this anymore. We'll exit out of there, and let's see what we've got. Our Q1 and our Q2. Here's the master here. We'll drag these over here for Q1. And then we'll do the same thing for Q2. Go to the master, drag these over to PixInsight. And we'll get rid of all the highs and lows. We don't care about high, we don't care about low, but this is S, sulfur, second quadrant. Minimize U. Close the high, close the low. This is oxygen. Second quadrant, minimize, close high, close low. This is H, second quadrant, minimize, close high, close low. S, quadrant 1, close high, close low. O, segment, quadrant 1, and finally H1. So the reason I like to minimize them is that I like to put my things in order like this. Sulfur, and then hydrogen, and then oxygen. Just feels better when they're more organized like that. So my very first step is a bit unconventional. I think most people probably do some fancy things before they stretch the image, but I don't mess around. I go right to stretching. So I'll bring up the histogram trans, and I bring up the stretch tool. Click on that guy, stretch him, drag the triangle up here, click OK, zero that out. Okay, that's S1. Okay. And while I'm in here, I'm going to go ahead and do an ACDNR on him as well. That's pretty good data actually for sulfur, don't you think? So we'll grab this ACDNR, just go like that. We'll let him run. I may pause this because the ACDNR takes a bit of time to run. You don't want to watch it run, so fast forwarding time here. Okay, it's done here. So that's ACDNR, and that's a stretch on S1. Go into H1, do the same thing here. Screen transformation, drag it over to histogram, click the square, zero that out, run the ACDNR on H1. Very strong data on H1. O1, same thing here, stretch him out. Zero that out, ACDNR. Okay, so I didn't show you that I did that on quadrant 2, but I did. So quadrant 1 and quadrant 2, I've done the stretch, and I've done the ACDNR on all of them. The next thing we need to do, since this is a 2-panel mosaic, is create a reference file. So the way I do that is with the star align tool. I'm going to open up H, since it's the strongest channel, H1 and H2. And what we're going to do is sort of glue those together like that, and then we're going to rotate them a little bit. So the way I do that is I go into Starline. I'm going to say, okay, H1, you're my reference. And for working mode, I'm going to say Mosaic. So I'm going to drag H1 triangle over to H2 and let it do its magic. What it's going to do is align the stars between H1 and H2 and mosaic them together for me, in fact creating a reference file. I'll show you in a minute why I need a reference file. Okay, here's our reference file. Now I'm going to go ahead and rotate that. Like this. Now I'm not too worried about the fact that the colors don't match right now. I don't care. All I really want to do is get a reference file with the stars lined up. The next thing I'm going to do with this is crop it to get rid of some of those edges there. So we'll just pick a corner up here and crop out the stuff we don't need. Okay, that's good. Crop that guy. Alright, now we're going to call this our reference file. Okay, now what we're going to do, okay, so now that we have the reference file, we're going to use that to position each of these 6 files into the correct quadrant location. So I do that using Starline. And this time you'll notice that I'll reference my ref file here, but the working mode this time is just going to be register match. Let's start with the S files. So here's S1 and here's S2. We're going to go ahead and run this star line on them, and we'll drag it there over to S2 first. So what that's going to do is orient S2 into the relative to the reference file. And basically, it's going to make a black spot on one side and put S2 on the other side. And we'll do the same thing on S1, basically putting these two files within their own quadrants with one black side on the other. We'll do that to all 6 files, and when we're done with that, then we'll use gradient merge mosaic to merge them into 1 sulfur, 1 hydrogen, 1 oxygen. So you can see here, here's the S2, and we're going to repeat that process for S1. And what I'm going to do is just save that off. So we'll say save as S2. Okay, and now that I've saved it, I don't need it anymore. And I'll minimize S2. Let's do the same thing to S1. Now, and we'll run this for S1 as well. Put it in its quadrant position. Okay, there's S1 in its quadrant position. We'll go ahead and save that. There. Okay. And close that file, minimize S1. Now we're going to repeat this process for H1, H2, O1, and O2. I won't show you guys how to do that because I'll assume that you know what I did. But now let me show you how to deal with that. So now we have these 2 files. Maybe I shouldn't have closed them. Here's S1, let's get rid of that. Here's S1 and S2. You can kind of see what they look like. Now we're going to use gradient merge mosaic tool to put those 2 guys together. So process, image integration, gradient merge mosaic. So S1, S2. And the way you do this, because you saved the file, you have to say add files. It's not a view, it's actually a file. So you go out there, find the 2 files and say open and add them in here. Now the things that I typically use the default settings in here. The types of combination, I'm going to use average. The shrink radius I use by default. The feather radius. But sometimes I have to play with the black point. And the reason that I do that is if, for example, if you have sulfur 2 and sulfur 1 and one is brighter than the other, setting the black point will basically make the brighter one achieve the gradient of the darker one. But by default I don't use it. But if you do have banding, you can use that. I'll show you what I mean here. So let's run gradient merge mosaic, and we'll merge those 2 together. Okay, now here's an example of what I'm talking about. you can see that S1 is a lot brighter than it is on the left side S2. And so the way I deal with that is I try again, gradient merge mosaic for the two files. I'm going to adjust the black point up 2 steps and run that guy again. Okay, and that looks a lot better to me. Looks a lot more natural. This is our S. That's our sulfur. So I don't need this guy, and I don't need that guy, and I don't need that guy. As you can see what we've done now, here's our S. It's an integration of the S1 and the S2. We're going to repeat this process for the H's and the O's. Now, I probably won't make you watch this, but I'm going to go ahead and do it. And when I'm done, I'll come back and show you the result. All right, you can see I've got them all done now. So I finished hydrogen and oxygen, and let's just have a look at them. So here's my sulfur, here's my hydrogen, and here's my oxygen. So obviously the hydrogen data is very strong, as you would expect. Most of the gas out there, dust out there is hydrogen. Very strong data, and the Astrotard 3 nanometer does a really good job of really putting the hydrogen stuff through. But I think the reason I like this target so much is the sulfur and the oxygen is quite a bit different than hydrogen. So we're going to get some really interesting colors when we mix this. So here's how the sulfur turned out. Here's the oxygen. It's going to be an interesting one. Let's mix it up and see how it looks. Okay, so Hubble Palette. If you watch my last video, and I assume you probably know how to do the Hubble Palette. SHO is RGB. Just mapping red to sulfur, green to hydrogen, blue to oxygen. Let's go ahead and just run that. Now, since hydrogen was so strong, this is primarily, a lot of green in there. But wow, just without any touching of this image at all, you can see it's going to be a really beautiful thing when we're done with it. At this point, what I would probably do is just do an ABE on it, an automatic background extraction, just to see if I can clean up some of that pink background. Yeah, we'll close that one out. Let's see, do I like that one better? It's got a lot of green in it. Or do I like this one better? I don't know. Let's run an SCNR on this to get rid of the green to see what that does to the background. Do I like that better? What does that look like up there in the corners compared to this one? Yeah, I guess I do. So I'm going to go ahead and blow this one away. Now we did an ABE on that. We ran an SCNR on it to get rid of the green. And so this will be our starting image. Let's just call this the SHO. This is our starting point. Okay, at this point, what I'm going to do is create some masks so I can start doing some stretching on this. So I'll just do an image, extract lightness. So just get a black and white luminous extraction from the SHO. And we'll save that. That's the SHO loom. We'll put that down here. And then we're going to make a clone of that. I'm going to change this one and call this one Nebula, or just Neb. We'll minimize that too. All right, so here's the SHO mask, loom mask, and here's the Neb mask. Now it's not a Neb mask yet until we get rid of those stars. So I like to use the star remover tool, which is that StarNet application, which can be found under Process, Module, where is it? Where is it? ETC, where is it? Yeah, it's under Cetra StarNet. Now this is a third-party plugin that you can install, and I have another video on that, so if you don't know how to do it, watch that video. And I'll reference it down in the comments here. Anyway, so run that star removal StarNet application on there. And on my little laptop here, this is going to take a while to run. So I'll come back when it's done. Well, it took a while, especially on this laptop, but it's done. Okay, so here's the nebula by itself with all three gases mixed together with no stars. So I'll use this as a mask to do some tweaking on the SHO file. Okay, I want to do that with the SHOL mask because that has the stars in it. So I also want to protect the stars from becoming dim. Okay, minimize that guy. Okay, invert this guy. Okay, protecting the nebula and the stars. Now we'll darken the background. Just like that. Okay. All right, we can remove that mask. Now we put the other mask back on it, the nebula mask. And now we're protecting the background, and now we're working on the nebula itself. So we're going to go in, first thing I'm going to do is play with the unsharp mask. And I usually like to zoom in a little bit, so I'll make a little preview mode, just draw a little box there, and then click on the preview, click on the unsharp mask preview, and now I can sort of toggle on and off and see what this is going to do as I sharpen that up. And it has the effect of sharpening the stars in the nebulas, which I don't like. Okay, I think I like that. So now we'll go back to this, we'll delete the preview, come back here, and we'll apply that to the image. I think I'm going to go with that, even though it is affecting my stars a little bit. Okay, so that's the unsharp mask. Now we're also going to apply the mask again to the nebula. And remind ourselves where I want to hide the background, protect the background. That's what we're doing. Okay, minimize the mask. Now I'm going to do a local histogram equalization on there. So again, we'll use our little previewer here. Just come in here and draw a box, and we'll run this preview on the preview. Before, after, before, after. And that makes a little bit more contrast in there. On a big image like this, probably it makes more sense to put it around 130 or so. So I get a larger radius going there. Before, after, before, after. Yeah, I like that. So let's try that on the big one now. Delete the preview. Drag this guy over there. Okay, so that's done. So let's zoom in there. So here's the before. Here's the after. You see the difference there? Before, after, before, after. It's really just pulling out some contrast between the gases, which I really like. But on a large file like that, I use a large setting like 120 or so. Okay, now the mask is still applied. It's protecting the background. Now we're going to do, we're almost done here, we're going to do a curve transformation on it. So now we're actually pushing and pulling on the colors. Alright, so the first thing I was going to go is to saturation, turn on our preview. For saturation, I'll just push it up like that. You see what it's doing. Here's the default. I'll just grab the curve and push it up, and you can see the effect that that's happening. It's turning the blue into a deeper blue and sort of affecting the red as well. Then I'm going to come over here to the CIEC component and sort of do the same thing here as well. Push that one up. Not too much, not as much, but you can see the effect here. It's really bringing out that azure blue in there, but it has, to me, the negative effect of making the dust clouds too orange. I don't like too much orange. I like more of a tan. So we'll tune that down with the A here. With the A, I'm going to set a point in the middle to protect the middle, and I'm just going to play with the darks here. You can see what the effect that's happening on the dust, right? So I like more of a beachy colored dust in my images, which what it turns down to mean is adding more green to the darker tones, and maybe adjusting this one as well. Yeah, that's looking good. The other thing I like to do maybe is adjust the brightness of the nebula to bring that up a little bit. Okay, I'm going to call that just about done. We'll save that guy. Close that. Do that. Remove the mask. There's my SHO, guys. What do you think? Now, and many of you have asked what's my process. This is it. It's not perfect, and you know, I probably do you guys probably do a lot of things differently, but it is what it is. Okay, now that we've got our SHO, I think I'll go ahead and run the true color as well. And I've got a script for that, true color from narrowband. So this one does 100% hydrogen, 20% sulfur and red, 8317 for oxygen and hydrogen for green and blue. Basically it's HOO with a little bit of sulfur added. So this will be quite red. And we'll run an ABE on that. Okay, we'll call that one the HSOO. We'll put our nebula mask on there, work on the background, make it a little bit darker, invert the mask, come in here to histogram trans, turn down the brightness, click OK. Close that, remove the mask, add the nebula mask, hide that, protecting the background. We're going to do, without a lot of checking, I'll just do an unsharp mask and a local histogram equalization on there. Okay, you can see I'm less concerned about the HSOO as I am the Hubble. I like the Hubble a lot better, but I still like to do this. Curve transformation, last step here. Go into saturation, push that guy up. Go into the C, push that guy up. And maybe adjust the green a little bit. Take some of the green out of it. Maybe blue's okay. Maybe turn up the brightness a little bit. Not too much. Let's try this. We'll put the center brightness there and put up the brightness for the background. There we go. Okay, we'll call that one almost done. Okay, we'll close that, remove the preview, remove the mask. Last thing, run an SCNR just to get rid of any residual green hanging on in there. Okay, that's it. So there's my true color facsimile, and then here's my SHO. What do you guys think? You asked for it, there it is. That's the process that I use. So it's not a trade secret necessarily, but these are my steps. For better or for worse, there they are. Anyway, thanks for your patience. Thanks for watching. Thanks for tuning in. I'll probably head back to Texas this weekend. So next week, I'll see you back in Dallas. Thanks for watching. See you next week.